How's it going, everybody? Trying a little bit of a different format with the video, something to have me more in the video itself, rather than just a voiceover or the talking head. What I wanted to go and cover is some of the more high-level technologies that are on the service provider blueprint for version 4.1, which is the blueprint that I'm currently studying for. I'm currently studying for the written exam, as we see right now, and one of the things that I've been doing is I've been going through and preparing for it. I've been doing a lot of reading and some minor labbing. The labbing has been pretty much consisting of hitting topics that I'm not as familiar with and a lot of higher level reading as I need to. So what I wanted to go through here today was a high level conceptual overview of what the different layer 2 technologies are for the blueprint, because layer 2 typically is not as well documented, it's not as well covered in any of the training that I've seen on the market. So a lot of it's just more like, okay, what are the layer 2 technologies out there? What are some of the terms that are out there for it? We're going to hit those topics as we go. So what we're going to talk about is we're going to take a IP cloud. So this could be an MPLS, this could be an IP-enabled cloud that a provider will build and then offer at a charge for the customer to use. So let's say we have an IP-enabled cloud. This is IP-enabled. And we have the IP cloud. And then this guy has built what platforms run in here. Obviously, it's going to be Cisco-based, but it could be CSR 1000V, it could be ASR, it could be 9K, it could be Nexus. It really doesn't make much of a difference. So there's a couple things that we need to understand about what layer 2 technologies are. So layer 2, in a nutshell, is going to be obviously the data link layer, right? So just like those of you that are familiar with the OSI model, it's layer 2 data link layer. So this is going to be propagating MAC addresses. There's a couple of things that need to be understood when it comes to understanding what layer 2 actually does, because I find a lot of it's a misunderstanding, and the reason I say that is because I had the misunderstanding. Back when I was studying for my routing and switching CCIE, there was a portion of the written exam that focused on layer 2 technologies, and I'm pretty sure I got those questions wrong because I simply didn't understand the technology. And so the exam for service provider focuses on both point-to-point, point-to-multipoint, and multipoint-to-multipoint. So we have the first one, which is going to be your point-to-point. And this guy here simply means it's going to be one CE device talking to another CE device over some sort of layer 2 circuit. Now this layer 2 circuit, as they're referred to, is typically referred to as a pseudo wire. Now a pseudo wire is actually what they call a targeted LDP session between two provider edge routers. So we'll say we're going to have provider edge here. We'll say we have a provider edge over here. What's going to end up happening, as long as these guys are able to reach each other via IP, then they'll be able to form a targeted LDP adjacency. The targeted LDP connection, whether that targeted LDP session is built via LDP, where the labeling gets there via LDP, whether it's via RSVP traffic engineering or TE, or BGP, or maybe segment routing. Whatever the method used is irrelevant. We're going to be focusing on LDP for our example. Now, all of these guys right here that we just talked about, those are going to be used for the transport label. The transport label is going to get you from PE to PE. Okay? We're not talking about this is the top label. We're not talking about the bottom label or the bottom of stack, which is also known as your VPN label. This is the bottom label, and this is what is actually the customer route. Okay? So when we're talking about this, we have the targeted LDP session, which I'm just going to draw a dashed line over to here. This guy right here is your targeted LDP. Targeted LVP meaning that this PE and this PE are not directly connected to each other. So it's a non-direct connected connection. So you set that up, the pseudo wire comes up, all is well. Now that's point to point. Point to point could be many different flavors. So that could be any transport over MPLS. That could be in what they call an Ethernet private line, which is simply going to be connectivity at the interface level, where you're not going to be focusing on a VLAN. And then you have EVPL, Ethernet Virtual Private Line. This one here is typically going to be facing the physical interface. And this guy right here is going to be focused on a VLAN, whatever that might be. Now that's not the only use case or the only the way that it works out, because these guys can be configured on a .1q sub interface, but I don't recommend you do that because you're taking some of the capabilities and functionality away from the network when you use a .1q sub interface. You're better off using what they call the service instance. The service instance is how the Ethernet flow point is leveraged. Because once I create the service instance and I tell it what it's going to be doing, I can then call the service instance from either a VFI via an XConnect, an L2 VFI for VPLS, or what have you. We're not going to really touch too much on Ethernet VPN because of the fact that it's there's not as much of a focus on the exam, because of the fact that things like, and I'll just put them over here off to the side, PBB EVPN, the actual operation of it is only supported on XRV, or I'm sorry, XR. The commands are supported in XRV. However, none of the layer 2 controls are supported in XR for any of these. So whether you're doing point to point, point to multi-point, multi-point to multi-point, iOS XR doesn't have the ability of, there's no data plane. So you can bring the control plane up. The one thing you'll notice is on XR, at least in my testing, Atom will work and EVPL will work. I cannot get a pseudo wire to form with EPL. So when I create the service instance, I give it a number. I'll say service instance 1, and I say Ethernet. So I say that, and then underneath the service instance, I need to specify what it is that I'm going to do with it. I need to say, like encapsulation, encap, whether you say, like, let's say you use the default command. Default means anything that comes to me, I'm taking everything in. And then you can specify that. You can do single VLAN, so encapsulation .1q, say 10, and then you could say second .1q 20, where this would be the provider's VLAN, and then the other one behind it would be the customer VLAN. There's a lot of things you can do with it. So the service instance would then get mapped to something else, because that's why you would use this. When you create this, you're creating an Ethernet flow point. The flow point is what you want to have, because depending on how you create this and depending on how you're working with it, you could be leveraging point to point, point to multi-point, or multi-point to multi-point, or simply any to any. Depends on how you want to work with it. Now there's some other terms that we need to talk about here as we're going along. When we talk about point to point, we're referring to as E-LAN, something along those lines, which would be your EPL or EVPL. Okay? When you talk about point to multi-point, if you see the term E-tree, this is what this means. This typically means that it's going to be an E-tree. So what's an E-tree? An E-tree is going to be your rooted connection, where you're doing, this one here is more like this. E-tree is more like this. and they're like that, where you have a hub and spoke type connectivity. And then you have your multi-point to multi-point. This is going to be your E-LAN, which is going to be your any-to-any or something more like this. Now, typically this is how VPLS is going to work. So this is your virtual private LAN service. Now VPLS itself is actually kind of interesting. You can use the service instance to work with all of these. And then what you do is you bridge them together and you tie the pseudo wire to a VFI, and you pull the VFI into a bridge domain. So all these lines that I'm drawing here, these green lines that I'm drawing up here, these are your pseudo wires, right? The pseudo wire connection between the routers. So let's say, for instance, I've got another PE over here, and I've got another PE over here. So they're all connected. And then what I end up doing is this right here is the E line. And maybe down to the customer here we have CE. And this guy connects up here. And he's just sending VLAN 1, right? Maybe he doesn't really care. So this might be in cap default. Down here we might have another CE. And this guy down here, he might be connected. And this guy here is this CE wants to send VLANs 10 through 20. So what you would do is underneath the encapsulation.1q, you would say encap.1q, and you would say 10 through 20. And that would allow this connection right here to basically be a trunk link between the CE and the PE. Now what happens when you do this, whether it's this guy here or this guy down here or even just a single VLAN or even the Q and Q or .1q inside of .1q, you strip this off, right? You strip these off. You strip off the first, second VLAN header, and what you end up doing is the providers, if you're doing Q and Q, you actually send the providers tag across that goes along, but the customer tag gets popped. So it gets popped, and then down over here, you have another CE, and this guy is here. Maybe this one's 10 through 20 as well. Now, the service instance here, you're creating 10 through 20. You're not doing .10 and .20 and .30, etc. You're not doing this on the provider side. You're saying encapsulation.1q underneath the service instance. So if I was to be more specific here and say, let's say on this interface right here, whatever that interface might be, you would say service instance 10 Ethernet. You would specify encap.1q 10 through 20, and that's all you would type in. And then that would apply that to there. Then the service instance would get tied to your XConnect layer 2 VFI. So you could type in L2 VPN, XConnect context, and you would specify member. You would specify member pseudo wire, say 10, and then you would map that there, and then you would go underneath the member and specify service instance 10, right? And that's how you would get your point to point. If I'm going to do a VPLS connection, something like this, where all these routers are talking to each other, what's going to end up happening is they have to have some sort of communication between them. And this guy over here. So you have a full mesh of communication, right? This is where the VPLS comes into play. And then you would say, on this PE you would have, let's say PE1, PE2, PE3, and PE4 over here. So you'd have a pseudo wire 14 and pseudo wire 13 and pseudo wire 12 here. And these would connect all these. PE1 would be connected to PE2, 3, and 4, and PE4 would be connected to PE1, 2, and 3, and it would go all the way around. Well, that works, and then you would have your, change this over to be a VFI. You would map all your pseudo wires to this. Pseudo wire, you know, let's say on here, we'll say is going to be 14, 13, and 12, for instance. And then you would create a bridge domain. The bridge domain would come in, bridge domain 10, and you would say, you'd grab the member, and then you would tie the service instance to that, and then would allow you to communicate that across the wire. So you would say the VFI would be one member, and then you'd have the service instance as another. And then what you would be doing is you'd be bundling these three pseudo wires here to the VFI, right? That's where you're calling the VFI and here. And the service instance would get mapped to this guy right here. So you're tying the VFI, which is the communication between these guys, to here, to this, to here, and then the service instance gets mapped there. So you'd have, that's where the Ethernet flow point comes into play. Because then you're able to, the Ethernet, the EFP is able to map those communications back and forth to the individual pseudo wires so they know where things are going. The bad thing about VPLS is MAC propagation happens in the data plane. You're not talking about PBB EVPN where you are propagating via BGP or BGP EVPN, depending on how you want to look at it. Now, that's the bad thing, because if I have all these connections here, then let's say, for instance, I want to create some sort of redundancy where I want to have multiple connections going out, and I want to maybe group these together, right? So I have failover in a pseudo wire group, and I want to bundle them together so that I have automatic failover, or maybe I'm preferring this guy out here via MPLS traffic engineering, something along those lines. Well, one of these connections, let's say this guy here is primary, this guy is standby. One will have to be primary, one will have to be standby. Okay, why? Well, because if you don't, and they're both primary, they're both forwarding, you're going to have a loop. Because VPLS, if you have an active-active connection, will propagate the information out from both pseudo wires. So with that capability of being a data plane, you have to the split horizon or the spanning tree in the core has to kick in and basically say, no, you can't do that. One of them has to be in standby. You can pick which one is, but now you have a full mesh of stuff in the middle here, right? Well, that works, but it's a lot of configuration. There's another variation of what they call hierarchical VPLS, HVPLS. What VPLS does, in a nutshell, is it takes this same logic here and it compacts it. So instead of me having all these connections going back and forth, I have a provider, another provider, another provider, and then I have PE, 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 and I have PE. And then what I can do is I build a full mesh between these guys, and then I simply will, on the provider edge routers, I will come up here and run a link to like this. I will do a full mesh or something like this. And if I'm so inclined, I could even go a tertiary connection so that I have a primary, secondary, and a fallback if need be. Now, these guys right here are called network provider edge, and these guys over here are considered user provider edge. This is the core, this is the edge. That's one of the things you want to be careful here. And NPE and UPE are your differentiating terms. So I would use the VFI over here, and I would use XConnect over here to get the connections up and running. So I would do point-to-point pseudo wire here, and I would do full mesh in here. This is going to allow a lot of scale. So that's going to give me that capability of being able to broaden out. Now, I'm sure you guys have probably heard of the BGP auto-discovery capability. Pretty cool stuff. I can sit there and learn instead of having to manually configure all of this, I can use BGP auto-discovery with either BGP or LDP signaling. So that's going to come into play when you have a very large environment, bigger than what I've got drawn up here, and you want to be able to propagate the information as far as you need to. Now, the cool thing about it is because it's BGP auto-discovery, there are some caveats that come into play. And LDP I find to be easier than BGP. and Cisco went LVP, Juniper went BGP, and there's an RFC for it, and BGP is a little bit more complicated. There's some more math involved, and basically the idea behind the math is, and I'm still struggling a little bit with that portion of it, because it's a lot, to me, it's like once math gets involved, you start to lose my interest. I just can't stand math. But what you end up getting is you end up getting a, for lack of a better term, without having a better term, like there's like a check or like a sanity check. You want to make sure that you're not propagating labels for an already existing connection. So there's a mechanism built into BGP auto discovery with BGP signaling to make sure that PE4 doesn't use the same label bindings as PE3. Basically, is what it comes down to. So we have that come into play. Now, you take that kind of concept and you run with it. Now, VPLS, HVPLS allows you to scale quite nicely. And one of the reasons you might have heard this thing called pseudo-wire stitching or multi-segment pseudo-wire, or they kind of refer to it as layer 3 VPN over MPLS traffic engineering tunnels. The idea here is if I wanted like implement traffic engineering in the network, I could take the existing network, either a VPLS or an HVPLS, and I can go ahead and run these connections, and I can have different traffic engineering scenarios in play, to where I can do PE to PE pseudo-wire or traffic engineering tunnels. But the cool thing about TE is it doesn't require you to do it like LDP, where I don't have to come in here because TE doesn't necessarily leverage LDP. It relies on an RSVP with the signaling between the connection points. So you have the concept of the head end and the tail end. And all TE tunnels are unidirectional, meaning the head end to the tail end connection, this being whatever router you set as destination, you might have the tail end as, a TE tunnel, right? But on the way back, from the tail end to the head end, it might be LDP. So it really depends on the situation at hand. Traffic engineering tunnels are always unidirectional. So I can get there via TE tunnel, but I come back via LDP. So that means I can have, let's say, PE1 going to provider 1. This is LDP. And then from provider 1 to provider 2, this is TE. And then from provider 2 to provider 3, this is TE. And then provider 2 to PE3, this is TE. But the connection from PE3 back to PE1, this path right here, this is all LDP. I can have a mixture of them. I can do provider core to provider core TE. I can do provider core to provider edge to provider core, provider edge to provider edge. It really depends on what I want to run with. It's up to you. So we're going to be hitting those topics as we get into them a little bit more in detail. But that's the general high-level overview of how you do this. Now, in the access, when you're dealing with UPE or HVPLS, you can either do MPLS to here, or you can do Q and Q. And it really depends on how you want to work with that. I found a pretty easy way through a friend of mine who's already taken and passed the service provider exam, that you can run inside of ESXi, you can run Q and Q in the access. We're going to be touching that if you follow the Rikers Island training course. I will be hitting that and how that would come into play. Now, one of the last things I want to touch on is how EVPN is different than VPLS and HVPLS. Conceptually, they do pretty much the same thing. They allow you to communicate customer edge to customer edge via layer 2, because with everything that I just said, all of this stuff in the middle, all this fancy dancy stuff, CE1 and CE2, they appear as they are directly connected to each other via CDP, via trace route, because these connections in the middle here are simply pseudo wires. They're point-to-point layer 2 connections. So that's one of the things to keep in the back of your mind as you're dealing with an understanding layer 2 VPN and how it comes into play. Now, where VPN comes into play, and let me go ahead and erase the whiteboard real quick. because I need to make a little bit of room. Go ahead and just get rid of some of this stuff. The thing that I find a lot of people have a hard time with EVPN is the concept of control plane versus data plane separation and propagation of information. So what does all that mean? There's a lot of fancy words to say, right? Well, basically the idea here is if I am running with EVPN, I'll say I have provider edge and I have provider edge, say 1 and 2, then I have customer edge. Then I have provider edge 3 and I have provider edge 4 and I have customer edge. The way this would work is these guys would have connections like this, full mesh, right? And then this guy up here would have it, and this guy up here would have it. Now, I'm not going to go into the nitty-gritty details. I'm going to, like I said, stay high level. Where VPLS and HVPLS fall flat on their face here is only one connection can be active at a time. So that would mean that if I'm going to be taking data from customer edge 1 and sending it to customer edge 2, with VPLS, you would be propagating the MAC addresses this way, this way, this way, this way, this way, this way. I mean, you get the point. It'd be propagating it, but it's in the data plane, which means what? I can loop. I don't want to have a loop. So rather than doing that, what you end up getting is you get what the concept of a BMAC and a CMAC. What ends up happening here is the customer MAC is learned from the customer onto the provider. So the customer MAC is built in that particular setup, and then what ends up happening is the BMAC is advertised and saying, if you want to reach this CMAC, point it towards this BMAC. And both these guys here will say BMAC 1. We have BMAC 1 here and BMAC 1 here. They're both advertising the same backbone MAC address. Go ahead and point, if you want to reach this CMAC, this customer MAC address, point it to this backbone MAC address, and then when PE1 and PE2 get it, go ahead and they'll forward it on. Because what you're doing then is it becomes a BGP layer 2 advertisement in the control plane rather than a VPLS MAC address propagation in the data plane. So it allows you to basically prevent loops in the network and scale it. So this is where you come into your 802.1AH. So you get situations like that where you get MAC and MAC. So MAC and MAC is simply stated is the provider edges have, you could theoretically say that maybe this connection right here is maybe a layer 2 bundle. Maybe your ASR 9K is port channel down to customer edge 2 somehow. Maybe this is an ME3800. Something along those lines. So these two devices right here appear as one upstream switch or one upstream router, depending on how you want to look at it. But they advertise the same, and we'll say this is BMAC 2. This is BMAC 2. And this is this is CMAC 2. This is CMAC 1. So when I want to go here and propagate information, I'm going to use the routing table. So what will end up happening here is PE3 and 4 will say, in order to get to CMAC 1, forward off to BMAC 1. In order to get to CMAC 1, forward to BMAC 1. In order to get to CMAC 2, forward to BMAC 2. Same thing up here. CMAC 2, go to BMAC 2. Because you got two devices advertising the same information, they know what's going on because they have a control plane connection between them, and then they can route traffic based off of however the traffic is going. So it leverages that capability, and what ends up happening, and it's been a while since I've looked at the documentation, but basically what you're doing is you're taking and you're sending a PBB header, provider backbone bridging. You're sending this header and you're encapsulating all of this information inside of a PBB header, and you're sending it via LDP, sending out the wire. Now this can be segment routed, which is another topic I'll discuss in another video, because I think segment routing is pretty cool. Only supported on XR at the time. I do have a version of iOS XE on the CSRs of 3.17 that I will be playing around with segment routing. The other one I want to mess around with a little bit more is BGP link. What's link? That's LS. I don't remember what LS stands for off the top of my head. But basically, what you're doing with BGP is you're basically taking the individual, the head end for traffic engineering. Both segment routing SR and BGP LS are basically traffic engineering advanced capabilities. So BGP LS link state, that's it. BGP link state. And you're taking BGP link state and segment routing, and you are building a database which has what they call the path computation. The path computation element, the PCE, takes information from all of the sources in the network. So it takes information from here, 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 and here. This goes up to the PCE. He has visibility to everything, kind of like an open flow kind of look. And he's able to take that information, point it to the PCE, and the PCE can look at the network. It'd be kind of like, if I'm driving to work and I pull up my phone, I type in, the address of where I'm going to be heading that day, and I pull it up, and then I type it in. Google can let me know based off of real-time traffic congestion and real-time traffic reports, hey, the normal interstate path that you take, well, there's a delay of 20 minutes here because of, whatever problem. If you get off here, drive up 5 miles here, cut underneath the interstate and go up this way, you're going to cut 11 minutes off your travel time. So I get off, and normally it would have taken me, say 40 minutes to get to work, but because of the fact that, there's that additional 20-minute delay, that would have taken me an hour, but because of the fact that I jumped off the interstate because Google said, hey, there's a better route, take this path, I was able to get to work in, 45 minutes versus an hour. So there are things that come into play, and that's what segment routing and BGP link state are allowing you to do. I'll be covering these topics in upcoming videos, but I want to talk about high level about layer 2 connectivity because I feel like it's one of those things that not a lot of, that hasn't been really hit. So for those of you that are interested in knowing, I'll also be hitting things like VXLAN and Lisp and unified MPLS. Pretty much if it's a topic on the CCIE routing and switching or CCIE service provider blueprints, I'll be doing a video like this. And let me know in the comments below if you would like to see more videos like this, where I get on a whiteboard and I just talk, and you guys can see the breakdown rather than just being me overlay. If you say, you know what, we really don't want to see you, we just want to hear what you had to say, well, that's fair too. I'm just trying to get an idea. I'd like to take this format right here and whiteboard, and then go ahead and allow you guys to, that'd be the whiteboarding instead of me, just talking on a whiteboard and drawing. Same concept. I just like to be, feel like I'm up and I'm moving around. Let me know what you think. I might incorporate this in some of my upcoming Rikers Island courses as we go forward. But you guys have been awesome. Thank you so much for stopping by, and we'll catch you guys in the next video. Till next time, guys, take it easy.